complete the table below. And once we've completed this table, we're going to be looking for some patterns. So let's kind of be thinking about patterns as we go through and complete it. So take a look at what we have here. In our first column, we're given some different values for x. And then in each one of these columns, we're being asked to take that x value and raise it to a different exponent. Here we're going to raise it to the second, and then to the third, then to the fourth power, and then to the fifth power. So I've gone ahead and done the substitution steps all the way through. So now all we need to do is kind of do that evaluating piece. So in this first one, we have negative 2 raised to the second power. So negative 2 raised to the second power, well, just think about that as negative 2 times negative 2, right? The negative is holding on with the parentheses. So negative times a negative is a positive, and 2 times 2 is 4. Now if we take negative 2 and raise it to the third power, that would throw another negative on there, wouldn't it? So we already know that negative 2 times negative 2 is negative 4, or sorry, positive 4. And if I take positive 4 times a negative 2, positive times a negative is a negative, and 4 times 2 is 8. Okay? So negative 2 to the third power is negative 8. Now what if we throw another negative on there? Well, now notice what we've got. We've got this first pair of negative 2's being multiplied together to give me positive 4. The second pair would also multiply together to give me positive 4. Positive 4 times positive 4 would give me positive 16. So notice we started positive with raised to the second power, and then the 3 brought it negative. When we raise it to the fourth power, it's back to positive. If we throw on another negative 2, now what have we got? Well, we've got these two negatives giving me a positive. I've got these two negatives multiplying to give me a positive. But then I've got one more negative thrown on there. So that odd number of negatives takes me back to negative again. And when I take all of this that I already have was up to 16, and I multiply in another 2, that's going to give me negative 32. Okay, so look at our pattern here. We go positive, negative, positive, negative. Let's see what we've got down here. If we take negative 1 to the second power, well, negative times a negative is a positive, and 1 times 1 is just 1. Negative 1 to the third power, well, we have negative times negative is a positive, but then we throw in one more negative, just like we saw up here when I had 3 factors of negative 2. That brought me back negative, and just 1 to raise to any power is just going to give me the 1. Negative 1 to the fourth is going to take me back to positive 1, and negative 1 to the fifth takes me back to negative 1. Now let's take a look at zeros. 0 to the second power is 0. 0 times 0 is 0. 0 times 0 times 0 is 0. 0 times 0 times 0 times 0, when I raise it to the fourth power, notice nothing very interesting happens with 0 here. 0 raised to any power is always going to give me 0. Now when I come down here with positive 1 raised to these powers, well, we're going to find something kind of similar here. 1 raised to the second power is just 1. 1 times 1 is 1. 1 raised to the third power, 1 times 1 times 1 is 1. 1 raised to the fourth power, 1 times 1 times 1 times 1, always 1. So 1 raised to any power is always going to give me 1, just like 0 raised to any power is always going to give me 0. And our last one, 2 squared gives me 4, and 2 to the third power gives me 8. Notice that these numbers are corresponding to the numbers that I came up with up on top, except that because this is a positive 2, we don't have to worry about the signs, because positives raised to any power are always going to end up with a positive here, right? Because there's no negative signs to have to keep track of. Then we have 16, and we have 32. So let's see if we can summarize some information here. If an exponent is even, notice our exponents are even column, x squared and x to the fourth. Notice that my results are always going to be either positive or 0. So we can say the result will be non-negative. But if the exponent is odd, that we can see that the sign of my answer is going to change depending on the sign of the base. So the result will be the same sign as the sign of the base. The same sign as base. And that's our rules.